In this video, we will show you the basics for the operation of the grounding grid module of Southwire Electric. We will describe the process to create a grid, compute the grid parameters, and finally we will print grounding grid reports. The grounding grid design requires the creation of a specific project. This is because the file format of the grounding grid differs from the format used for conductors and cable trays and conduits. To create a grounding grid design project, select the option Project in the main menu, then select New. This will show the primary window. Here select the ground grid in the Project Type section, located on the left. Then type the project name. Select the directory where the project file will be saved by pressing the 3 points button. This will open a dialog box where you can select the drive in the lower left combo box. Then select the location by clicking the Directories box and the level where the project directory will be created. Press the OK button to save the information and close this window. After creating the project file, the References window will appear. Here you must enter the project name, the customer name, project location, and the name that will define the documents and the reports printed by the software. Following that information, we need to enter the name of the person populating the information with an email and a phone number. After that, the information of the person that will be reviewing the project, and finally the information of the person that will approve the reports. To validate and save this information, press the OK button. If you want to edit the information of the References window later, you can select the option Views in the main menu, and then after that, select References. To start creating grid designs, select the option Views in the main menu, and then Grounding Grid, or select the Grounding Grid icon in the toolbar. A table or data grid will appear with a grid toolbar. In this grid, each record represents a specific grounding grid design. You can create a base grid design, copy it, and work in variations in a new copy. In this icon, you can also delete the grounding grid design, export the images of the grid design, print a comprehensive report of the record highlighted in the data grid, copy all the analysis into a clipboard, and finally you can close the data grid. To create a new grounding grid design, press the Add icon in the toolbar. This will open a primary floating window with a grid layout in the back. Please note that you can click and hold on the heading of this window to locate the window in the position that is more convenient for you. This window has a common area for the design name and 5 tabs to enter the information for the grid layout for the technical data used for this project grid analysis. In the back, you will see the grounding grid layout with the default values. We should remember that Southwire Electric, you can create rectangular or squared grid modules. Type the name of the study or design for your grounding grid. Next, select the Layout tab. Here you should define the grid total dimensions for length and width. Then define the number of horizontal and vertical conductors in the grid. Notice that when typing these two fields, the horizontal space and the vertical space between the conductor fields are updated accordingly. You can also see that while you are typing these values, the design in the background is being updated to reflect the grid layout and dimension notes. Next, select the conductor size. If you want the conductor to be verified to withstand the fault current, select the checkbox. If the conductor was selected to withstand ground corrosion, leave this field unchecked. Then select the conductor material and later select if the connectors in the grid are mechanical or welded. Then select the Rods tab. Enter the grounding rod length in meters. Typical rod diameters in meters will appear in the combo box. Here you can select one of the diameters in the list or type the diameter for the grounding rods. Once you have defined the rods, it is time to locate them in the grid layout. Press the Add button and you will notice that the button is indented, indicating that you are in the addition mode, and then move the mouse pointer to the layout in the back. Select the intersection in the grid conductors where the grounding rods will be installed and click on the intersection. A circle will appear on the intersection to indicate the rod was included in the layout. Place as many rods as required in the design. Please consider that the rods can be placed in the grid conductor intersections. If you misplace a rod or if you want to remove a rod from the layout, press the delete button and then select the rod you want to remove in the layout. By clicking on the circle, the rod will be removed from the grid. You may have noticed that while you are adding or removing rods from the layout, the total rods field is updated as well as the table with the rod's position. This table shows the relative coordinates of the rod locations considering the grid origin point at the upper left. Relative coordinates are based on the number of grid conductors to the right or to the bottom of the origin where the rods are located. Now is the time to enter the soil information in the Soil tab. Here you should type the grid burial depth in meters and the thickness of the surface layer in meters. In the resistivity frame, you should identify 3 fields. The first one is to define the surface layer resistivity to be entered in ohms per meter. Type the value of the soil resistivity in the soil layer 1 box. This value should be obtained from the soil geoelectrical study performed where the grid will be installed. If the soil is not uniform and has a second layer with different resistivity, you should type the resistivity value in the soil layer 2 box. Sizer Electric calculates the grid resistivity using the Schwartz formula when there is a difference in the soil resistivity values. If the soil has a uniform resistivity, type the same value in the soil layer 1 and the soil layer 2 boxes. The 3-point button next to each resistivity box shows typical values for the resistivities based on the reference tables of the standard IEEE 80. Now let's define the electrical parameters for the grounding grid computation. Select the Electrical Parameters tab and enter the substation power in kVAs. Then enter the maximum resistance you have defined for the grid. In this text box, enter the single-phase fault current available in the substation, incoming line in amperes. See IEEE 80 for recommendations about the fault current to be used. Type the substation primary voltage. Then type the fault current growth factor. This value is between 1 and 5. Then type the division factor to define, in a per unit basis, the percentage of the fault current flowing through the grid, and finally type the fault time, that is the time the fault current will be flowing through the grid. This value is commonly the total fault clearing time of the protective device. Finally, select the Calculate tab. Here you will find a frame to define the tolerable voltages for a person 50 or 70 kilograms in weight. Once you have selected one option, press the Calculate button to see the computation results. When the computation is complete, the results of the computation and the conclusion from the analysis will be shown in the table. In this table, you will find the body tolerable voltages, mesh and touch voltages, grounding grid resistance, and the ground potential rise. You will also find the shape factor and the other factors required by the standard IEEE 80 to evaluate the design of the safe grounding grid. Identify the outputs and you can go back to the previous tabs to update the data entered in the Design a Safe Grid. Press the OK button to save your study and to close this window. Once you have completed the study, it will be shown in the data grid as a new record. See that the icon on the first column indicates with an OK mark if the design complies with the IEEE 80 recommendations, and an X if the design has deviations from these recommendations. To print a comprehensive report for your grounding grid computation, select the study record you want to print and press the Technical Report icon in the grid toolbar. This will open a report preview where you will find the data, criteria, and formulas used to verify the grounding grid design. The toolbar in this report preview allows you to export the report, change the report views, and navigate through the different document pages. You can also print this report by selecting the option Reports in the main menu, then select the study from the filtering window. Customize the report heading if required in the report name field. To see information entered for the analysis, print the grounding grid report from the option Reports in the main menu, and then select Grounding Grid. This will show a filtering window to select the studies you may want to print. Select the study by highlighting it in the list and customize the report heading if required. Press the OK button to continue. Here you can see a high-level report with the computation factors and results of the computation, as well as the layout printing. You can customize the grid layout colors used in the entry window and in the printing reports. To change the colors, select the option Tools in the main menu and then System Settings. In the Primary Configuration window, select the Grounding Grid Settings tab. Here you will find two columns of combo boxes. The column on the left is to change the colors used for the reports, and the column on the right is for the colors used in the design view or query. You can change the background colors, conductor colors, and dimension labels, as well as rod drawing colors. Press the OK button to validate data and to close the window. These are the basic steps to manage the Grounding Grid Design module for Sizer Electric. For detailed information, read the software manual or visit the help files included in the software in the option Help of the main menu. Thanks for your attention, and we recommend you see complimentary videos on conductor selection, conduit and cable tray sizing for a complete knowledge of the Sizer Electric software.